called the Cube or Dice Line Drawn Puzzle from January 2019. On a cube, draw connecting straight lines from edge of cube face to edge to form closed loops, so that the outlined number of shapes on each face equals the corresponding number that would be on a dice on that face. Note, on dice the numbers on opposite faces always add up to 7. So the examples. Example 1, as you can see, I've drawn the line on the front face and then it goes down to the edge which is adjacent the left face, and then it continues from that edge to the top edge which is adjacent the top face, and then it closes the loop. In example 2, as you can see, same sort of thing. Now example 3 has both of those together because the final solution will have multiple loops, and these numberings are how many shapes are on each face. So as you can see, the top face has 3 shapes enclosed by the edges of the face on the cube as well as the lines we drew. Therefore it would be dice number 3. The front face has 4, so it would be dice number 4, and in this example the left face would be 1, 2, 3, 4 as well. So it's not a correct solution, because dice don't have 2 4 faces. Alright, now to explain the rules. Straight lines from edge of face to edge. Lines need to loop around to connect to their start to make a closed loop. There could be multiple distinct loops as seen in previous example 3. Do not. No 2 lines from same loop on same face, i.e. no circling around twice or reflecting back into face in the one loop. So as you can see, that second cube on the right, that one singular line has looped back around and is drawing on the same face. That first one is reflecting back instead of, the first cube is reflecting back, that line on the first cube is reflecting back instead of extending onto a different face from the edge. Lines cannot split up or converge, so you can't do this in either direction. And lines cannot run on edge lengths of cube as shown, but they can go to the corners. There's also alternate rules which I will show on the screen now for a different style of puzzle. So hint 1 is the different arrangements of lines on a face which can equate to a certain number on the dice. So there's only a finite number of arrangements, and they are seen here. And second clue is, one way of visualizing this is to draw the cube as such, noting there is one face hidden, but that is the face that would have number 1 on a dice, and because the rules say number of shapes on a face, you can't draw any lines on it because it already has one shape, which is a square, the edges of the cube. The third hint. When a line crosses another line on a face or edge intersection, it must cross back again on another face or edge intersection to be able to reach its origin and connect loop to where it started. Therefore, the solution must contain an even number of crossed lines. Now, I don't know how I figured this out back in 2019, and I don't know if that's actually technically true. I guess it is, I have no idea. Can somebody give a proof for that as well? So, I'll visually show you what I mean. Back to this example 3, I'll point out the number of times it crosses, I'm not going to count it right now, and show that it's an even number. So does that always hold true? Maybe. Now I think the simplest way to solve this would be to project the surface area of the 3D shapes into a rectangular projection. So not a net, like you can net a cube and it looks like this. But it's a bit complicated to visualize because the adjacent edges, which in 3D do connect, in the net it's a bit harder to visualize that they connect. So if you did a topological projection like they do with a map with distortions, the edges would touch each other still, and it may be easier to visualize where the lines can connect to each other. But the problem with that is the lines you draw would not be straight, so you'd have to ensure that on your projection it's curved, but then once you put it back onto the shape it's straight, I believe. Another way to do this, which would be interesting, is if you 3D modeled the shape like a cube, and then you were able to rotate it on your computer, and you could draw on the cube, and it would show you what you're drawing, how it looks like in the projection, in the flat projection, or even the net. Doesn't need to be a distorted projection, on the net, just so then you can have that side-by-side visualization. That'd be a good little project for some retard to do. Maybe you could put that in your resume. And I was wondering if it can be formalized into a general mathematical equation to solve it for further shapes. So I guess maybe after this video I'll have a go at figuring out myself if it is possible with the next up Platonic solid, whatever that is, if that's a pentagon or a hexagon. Pentagon? Pentagram? Pentagon. I've got nothing to talk about because I'm going to save the second math thingo for part 2. Alright, it's been 11 minutes 40 seconds in recording time. One-shotted this bitch. It's probably going to be less than 8 minutes, so maybe I'll run through the rest of the video with other bullshit, who knows. Alright, bye.